So for graphing polynomial functions, we have to use all of the skills that we've learned before in the past. We know how to graph a quadratic. We know how to graph a linear by using tricks. Now in this case, when we're graphing large degreed polynomials, there are not really a lot of tricks that we can use, but we can use a lot of the facts that we know about polynomials to help guide us on what the graph is going to look like. So when we're graphing polynomials, first thing, we want to make a table of values. And these table of values, I'm going to emphasize, make the table of values in order. Okay? So before, we're used to the moral 5, 0, 1, negative 1, 2, negative 2. We're going to still use the moral 5 and maybe even a little bit more, but put them in order from least to greatest. So go negative 2, negative 1, 0, 1, 2, dot, dot, dot. Go in order from least to greatest, okay? If you want to start with negative 5, fine. Go negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. Just go in order, please, from least to greatest, okay, in ascending order. And then, besides making the table, you got to know the end behavior of functions. We have already talked about the fact that even functions are going to be up and up if the a is positive. And it's going to be down, down if the a is an odd function is going to be down and up if a is positive, and it's going to be up and down if a is negative. Okay, so keep this in mind, okay? We're going to graph the function x to the fourth plus x cubed minus 4x squared minus 4x. One thing immediately that we can tell, immediately, 100%, it's positive and even. So this is going to be an up and up. So we know that on both sides, on left side and on the right side of this graph, I'm going to be pointing up and up. Does that make sense so far? Pretty easy, right? So we're going to go ahead and plug in some values. So I'm going to go negative 2, negative 1, 0, 1, and 2. And let's see what we get here. When x is negative 2, y is 0. When x is negative 1, y is 0. When x is 0, y is 0. When x is 1, y is negative 6. And when x is 2, y is 0. Now, of course, this is not, by any stretch of the imagination, enough points to really have a detailed, accurate graph. But this is what we do. We found a bunch of zeros. We found a bunch of points, ordered pairs. So let's go ahead and graph these. So we got negative 2, 0. We've got negative 1, 0. We've got 0, 0. We've got 1, negative 6. And we've got 2, 0. Now, we know that we have 4 zeros here. Not only do we know that we have 4 zeros because we found the 4 zeros, but doesn't the degree tell me the maximum number of solutions that a polynomial function can have? So if I have a power of 4, it doesn't mean that I'm going to guaranteed have 4 solutions, but it means that I can have up to 4 solutions. All right? So everyone with me so far? So this makes sense that I have 4 solutions. It's valid. It makes sense. Now, how do we put this all together? Well, there is a location principle that states that between the zeros of any polynomial function, okay, between the zeros, there is a turning point. A turning point is going to be the curve. This is the turning point because I was going up, but now I'm turning down. This is the turning point because I was going down, now I'm going up. This is the turning point because I was going up, now I'm going down. This is the turning point because I was going down, now I'm going up. This is the turning point, I was going up, now I'm going down. This is the turning point, I was going down, now I'm going up. So between the zeros, between the solutions I have what's called a turning point. Okay? So let's fill in these gaps. What's a point between -2 and -1? -1.5. When I put in -1.5, I'm going to get roughly, approximately, -1.3. So at -1.5, I got -1.3. It's about right there. Now, between -1 and 0, what's a value in between those two? -0.5. When I put in -0.5, I'm going to get roughly 0.9. So, -0.5, 0.9, it's about there, almost at the 1. Almost at the 1. Bless you. Then I have between 0 and 2, I already have my 0 right there. Correct? I already have my 0 right there. So, let's graph this sucker. I know I'm going up and up. So I'm starting, I was going up, so I'm going down. Up and up. There were 4 zeros. There was 1, 2, 3 turning points. And that's how you graph. Yes?
Sir, how do you know that there aren't any like further?
Okay, the question is, how do you know there are no other turning points? What is the max number of solutions that I can have here for this, my man? So I have 1, 2, 3, 4 solutions. Between each solution, I'm going to have a turning point. So that means 1, 2, 3 turning points max for this particular case. Correct, sir. The question was, you won't have another random turning point? No. Turning points will be between solutions. Great question. Thank you. Yes, sir.
You always use a moral 5? You always use the 1.5 and the 0.5?
The question was, are you always going to use the -1.5 and the -0.5? No, it depends where the zeros are. It depends where the zeros are, my man. No, thank you. Great question. Does that kind of make sense so far? Yes, sir. Did I pick a point between 0 and 2? Okay, good question. You can. You can pick a point between 0 and 2, but didn't we already have a point between 0 and 2? So that's gonna that will work as my turning point. Thank you. Okay? This is gonna get better with practice, okay? This is gonna get better with practice. Let me explain one thing right quick though. Let me add this. Okay. If I've got, well, that's ugly. Okay. Sorry about that. There we go. Okay. If I've got the following here, and I've got this curve. Okay. Let me show you what happens here. Do you see how I have a 0 here? Okay. Eventually, I'm going to have a 0 here and a 0 here, correct? Do you see how in between the zeros, I have a turning point? In between the zeros, I have a turning point. That is called the location principle. I don't like the way they state it in the book. It doesn't really make sense. But basically what's happening here is between every 0, I have a turning point. And that's called the location principle. Cool? All right. Now, let's go back to where, yes? I'm sorry, could you repeat the question? Is there any way to find what the next 0 would be? Yes, by solving the solution, by factoring, or by using quadratic formula, by doing other algebraic procedures. Remember, what are the solutions, guys? The solutions, okay, in other words, the real zeros, okay, real zeros, don't they just equal the x-intercepts? So you make y 0 and you solve for x. All the x's you get, those are all of your solutions. Thank you. Yes. Is the turning point always going to be the midpoint? Yes. That's why it's between. Absolutely. Anything else? Are you sure? Okay. Thank you. Okay. Now, number 2. Determine the consecutive values of x between each real zero of the function. F of x equals x cubed minus 5x squared plus 3x plus 2 is located. Then draw the graph. Okay? Easy. Let's go ahead and make us a little table. Okay, we got x and y, of course, because we got our x independent and our y dependent. Yes. So anyways, you're going to go ahead and plug in values. Okay, so I'm going to have -2, -1, 0, 1, 2, 3. Let's see what we got there. -2, I got -32. -1, I got -7. 0, I got 2. 1, I got 1. 2, -4. 3, -7. Let's see if that gives us enough to work this out. I'm going to go ahead and just draw a table because I have large values. Okay, now, a student has already stated a very wise thing. This is a positive odd root. So I am going from down to up, down and up, down and up. Okay? So let's start plotting some of this. -2, let's make this down here -32. We got this bad boy right there. Then -1, -7. See how it's nice and easy to follow it in order? 0, 2. 0, 2. 1, 1. 2, -4. And 3, -7. Do I have enough there? Do I have enough points there? This is going to give me a graph that pretty much looks like this. Is that correct? So what's wrong? What do I need? What am I missing? You're missing a couple more points. I've got the down part. Do I have the up part yet? So I need more points. So let's go 4 and 5. When x is 4, y is -2. When x is 5, y is 17. So when x is 4, it's -2. When x is 5, 17. Now I'm golden. And my location principle is accurate. Between these zeros, do I have a turning point? Between these zeros, do I have a turning point? That's it. You're done. I'm not looking for crazy, accuracy here. I'm looking for logic. It's down and up. The points were correct. I had a turning point between my zeros. I'm golden. Yes, I just said that. I just said that. Does that make sense so far? Yes. I didn't tell the ordered points. What are you talking about? I just made my graph. I was just verifying that my graph is correct. Do I have a turning point between these two zeros? Do I have a turning point between these two zeros? Then I did it correctly. Yes. So, let us continue, but now let's introduce another concept for these turning points. What do those turning points remind you of? Thank you. I was told that it reminded them of vertices, a vertex. Yes, very good. Turning points are kind of like vertices. They're not really truly vertices, because it's not a quadratic equation, but they perform the same function, being a maximum or minimum. However, when we had a parabola or a quadratic equation, okay, let me explain what I'm about to say here. When we had a quadratic equation, and you had this is one function, so this would have been called the minimum. If I went up here like this was the max. However, in polynomial functions that are larger degrees than powers of 2 or 3, you're going to have a lot of turning points. So those are called local mins and local maxes. Let me explain what I mean by local. When I'm talking about local, I'm talking about their actual location. So if I were to do something like this, okay, I have one local max. This is the local max between these two zeros. That's my turning point. You feel me? This is the local minimum between these two zeros. This is the local max between these two zeros. This is the local minimum between these two zeros. So I cannot say to you one particular, find the max. I can say to you, find the local max and min. The local max and min here, it's going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5.5. So that's negative 5 of 5.5. That's 1.5, 1, 2, 3, 3.5, 1.5, 3.5. That's 1, 2, 3, 4, 5, 5.5, 2.5. You feel me? So the turning points are the local max or min between those two zeros. Now let's go back. Okay. So relative max and min also serve as a turning point. Okay, it also serves as a turning point. And the best way to show you this is to do an example. They want you to graph f of x equals x cubed minus 3x squared plus 5. And they want you to estimate the x coordinates at which the relative maxima and relative minima occur. Okay? So, let's do what I already taught you to do. First, let's make a table of values. Thank you very much. Excellent. We're going to start with negative 2, negative 1, 0, 1, 2, and let's go 3. So negative 2, y is negative 15. When x is negative 1, y is 1. When x is 0, it's 5. When x is 1, it's 3. When x is 2, it's 1. When x is 3, it's 5. Okay, which direction is the end behavior gonna flow in? It's positive and odd, down and up, excellent. So negative 2, 15. Let's go on the y-axis by threes, okay, folks? So negative 2, 3, 6, 9, 12. Should be negative. Pay attention. Negative 2, 3, 6, 9, 12, 15. So that's negative 50. We're going by threes, okay? Then negative 1, 1 would be like about right there. 0, 5, 3, 6, so it's going to be about right here. 1, 3, we got 1, 3, we're going by threes, right? Yeah, so 1, 3, and we've got 2, 1, which is about right there, and then we've got 3, 5, so it's about right there. Now I know this is going to go down and up, so I've got enough for my pattern here. Now, I'm going to show you a couple things that are happening here. First of all, let's answer the question. What's the local max and what's the local min? Yes? The local max would be? The local max is right here. The local max is right here. Okay? So it'd be 0, 5 is the actual local max. The value of the local max would be 5. What's my local min?
It's
2, 1. Right here. The local min is 2, 1. Yes.
something that I've noticed.
Okay.
Like if you have x to the fourth, you'll have secret.
Correct. We had stated that already. The degree tells you the number of possible solutions. Then the number of turning points are going to be the number of possible solutions minus 1. Very good. Very good. Very good. Okay? Now, let me see what else I got here prepped for you guys. Okay. Didn't we just do that? Yeah, I already did it. Oh well. We already did it. That's in vain. I'm sorry. Okay, now, let me give you a couple examples from the homework, and we'll go over what it is we have to do, because it's very simple. Okay? So, let's just try this little practice problem. For the practice problem, it tells us a graph using a table of values. B says determine the consecutive x values between which each real zero is located. So determine consecutive values of x.
Interruption, but at this time we would ask that the freshman class with their books and book bags
Between
please report to the gym. We ask that the boys report quietly and respectfully
which
that they report to the gym for
each
again the freshman class
real zero
with their books and book bags. Thank you.
is located. And C, they want you to find the relative min and max. And they're nice, they say estimate. Okay? So those are the directions Let's go ahead and try one. F of x equals negative x cubed minus 4x squared. Yes. The relative min and the max is just what we talked about. You can have 4 different maxes or 4 different minimums. I just finished talking about that. That's a relative max. That's a relative max. That's a relative min. That's a relative min. Local, yeah. Yeah. Relative max is the same thing as a local max or local min. Okay, so let's get a table going here. Let's go negative 2, negative 1, 0, 1, 2, and let's go 3. Let's see if that gives us enough. When x is negative 2, y is when x is negative 2, y is, okay, I got negative times negative 2 cubed minus 4 times negative 2 squared. That's going to be negative 8 minus 16.
No, that's going to be positive.
Positive 8 minus 16, which is going to be negative 8. Okay. When x is negative 1, what do we got? 1 minus 4 is going to be negative 3. Thank you. When x is 0, y is 0. When x is 1,
That's going to be
negative 5. Very good. When x is 2, when x is 2, we got negative 8. Negative 8 minus 16, negative 24. Very good. And when x is 3, it's going to be negative 27, right? Minus 36. So it's negative 63. Very good. Okay? Make sure you guys get that, please. Please, please, please. Everyone with me so far? Okay. So now let's graph this sucker. We're going to find out if we need to do 4 and 5 now. We have to first graph what we have, son. We're going to have to estimate here, of course. Okay, so let's just, let's see. The y's are going, there'll be quite a few. So let's do the y's by, I don't know, let's do it by 5s. That'll be 12. Let's go by, we could go by, let's go by 6s. 6, 12, 18, 24, 30, 36. And then 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's negative 66. And that's negative 6. And then the x's, we can go by 1s. All right, let's see what we got. Negative 2, negative 8. So that's about right there. I got negative 1, negative 3. So it's about right here in between, the midway, halfway point. 0, 0. 1, negative 5. It's about right there. We got 2, negative 24. So that's 1, 2, 3, 4. And then we got 3, negative 63. So that's all the way back down here. And then the student who said we need more points is absolutely right. I know you did. Thank you. So let's try 4 and 5. What's the value of y of f of x when x is 4? Negative 128? $64. Yeah, negative 128. Wow, that's going to go way deep. How about 5? This is never going to come back up. Yeah, we're going further and further into the abyss here. Let's switch it around. Let's go to the negative side. Okay, let's go to the negative. Because remember, what's the end behavior here? Up and down. So we have the down part. We need the up part. So let's try negative 3. What would it be if it's negative 3?
Minus 36.
That's negative 9.
Negative 9. 27 minus 36.
27? Negative 27. It'd be 27 minus 36. So that'd be negative 9. Okay, so negative 3, negative 9. We're like about there. We're getting closer. How about negative 4? Okay, perfect. Negative 4, 0. Now we've got it. So we've got here like this. It satisfies my up and down. What is my relative or my local max and my local min, my relative min and max? Okay, my local max or my relative max is 0, 0. What about my min? What's my relative min or my local min? Negative 3, negative 9. Very good. Now, the one question we haven't answered is this. Determine the consecutive values of x between which each real 0 is located. So, think about it, y'all. Isn't this and this a 0? So what are the x values in between those zeros? Isn't x here greater than or equal to 1, 2, 3, 4, negative 4? But it's it never okay. It never goes there. Okay, no worries. My drawing was off. I apologize. So my x is going to be greater than or equal to negative 4, but less than or equal to 0. That's it. Determine the consecutive values of x between each real 0 is located. And that's it. Okay? We already found the min, and we already found the max, and that's it. Okay? If it was going up and up, then that means that this side here had to start coming up at some point. But it did not. So that's the way it is.